Benvenuti a questo nuovo seminario delle nuove tecnologie broadcast di Funk e Junk. Quest'oggi parleremo non solo di broadcast TV, ma estenderemo a tutto ciò che è il processing nel mondo della post-produzione, cinema, musicale e non solo. Oggi parleremo di Loudness Control, Processing TV, Dolby Atmos ed ATSC 3.0 Technology. Quest'oggi avremo il nostro seminario in lingua inglese, avremo anche ospiti i nostri partner di Telos Alliance. Infatti avremo con noi Artur Podzorski di Telos. Buongiorno Artur. I say you welcome everybody to all in this new webinar. We will have this new seminar about the new processing technology about TV, but not only TV processing. We'll talk about Dolby Atmos. We will talk about loudness control. And today we have with us our partner guys from Telos Alliance. I say hello to Artur Podzorski from Linear Acoustic and Telos. Hello, Artur.
Hello. Very warm greetings from Warsaw.
I'm very happy for you. I know that you are in Poland, but it seems that you are everywhere. You are not in Cracovia today, or it is something similar.
Well, this is what you see behind me. This is just a small copy from the original that's in Warsaw. So you know. Anyway, thanks to today's technology, we can be anywhere. So it's beautiful, and the thing that I will be presenting will be the part of this story. It will be the part where we can show simply the different possibilities of, well, let's say, production.
Okay, yes, thank you. In fact, we will have also Friedemann Kootz from Junger in Germany. Hello, Friedemann.
Hello from Berlin. I'm sitting here with in lockdown in my home office in my studio in Berlin. So I'm probably the one with a real background in this case.
Yes, you are right. And we have to say hello to the last but not least, Larry Schindel, from US. Hello, Larry.
Good morning. Good morning from California.
Good morning from Italy. And thank you a lot to you because I think it's a little bit difficult for you because you are stay in San Francisco. Now you are 9 hours before Italian time, right? And are 6 in the morning at the moment.
Yeah, the sun is just coming up here. So good morning.
The sun is up, and I thank you to stay with us. And we can send to you a virtual coffee, Italian espresso coffee for you. Thank you for staying with us.
Perfect. My pleasure.
Welcome. I say hello to everybody, and today we will start with Friedemann Kootz from Junger, as I told before, and Friedemann will talk about the technology that can present today to us. Please, Friedemann.
Right. So welcome again. I'm going to introduce you to our current portfolio, to our technology, which is very heavily relying on all those necessary steps in production, in broadcasting that were already mentioned with the loudness control, for example, with all the automation stuff around, which is very, very important today. And of course, with the future technologies included in standards like ATSC 3.0. So I would like to share my screen because I have a little presentation that will guide me through this webinar. So Junger Audio, just as an explanation, you will at some point see probably the Vox Audio GmbH name. This needs a bit of explanation. It's the original Junger Audio company and brand was founded in 1990, so we're in our 30th year now. It was founded by Herbert and Irmgard Junger back then and developed into one of the big player companies in broadcast production, in audio processing, and specifically in real-time audio processing. So the company went quite well, but due to various reasons in 2018, we came into troubles, and the situation came up that we had to file for insolvency. And with the administrator, we were looking for a good solution to this situation, and we came up with 4 people from our company. Namely Manfred Ottenbreit, Stefan Waldeck, Benjamin Steinke, and me, Friedemann Kootz. And we founded a new company called Vox Audio. So Vox is just the abbreviation of our surname. So it's WOKS. And the new company made an arrangement with the administrator, and we bought almost all the assets from the original company. So what we have here is that Junger Audio turned from being a company on its own. It's a brand now. It's our brand of broadcast products with the exact same team in the background. So we managed to keep half of the people from the original company. We have all the developers with us. We have the administration with us. And the only thing we had to let go was our distribution. So we're now solely a development and technology company. And that's why we got in touch with our old friends from the Telos Alliance. And we brought those 2 companies together so that Telos Alliance is now our international sales and marketing team. And we are focusing on the development and implementation of the technology. So this is a very, very great combination of knowledge, of manpower, and we're very, very thankful that this happened in this way. So Vox Audio is the company in the back for the Junger Audio portfolio. We're still supporting all the old products. We still have the knowledge. People from our company are with Junger Audio for more than 24 years. So we've developed all this that is can be found everywhere in the broadcast market, and we still can help. We still develop. We still produce. We're still using the same contractors' work. Everything is just like before. So this is a very, very good solution for everybody here. So my name is, again, Friedemann Kootz. I'm one of the 4 founders of the Vox Audio GmbH, and I'm the managing CEO in a way. So I'm responsible specifically for product management and everything around this. As I said before, Junger Audio is a quite old company in audio terms, let's say. So we're 30 years old now. We're really have been from the very beginning. We've been into dynamics processing, which was always one of our main focuses. So what you see here, the first product in 1990 was the compressor 188. It's still analog, and it's this compressor is the foundation of all the dynamics processes that we've implemented all over the years. In fact, the original idea of this 188 compressor is still part of our compression algorithms that are in all of our products from until today. And just on a side note, the compressor you see on the top, this 188, is my personal device, which is in the rack right behind me. So we still use our stuff, even the older ones. Yeah, that's just if you want to get some bullet points on our company. So we go right on. The main difference to many other manufacturers, and this is I would like to emphasize because of our situation with Linear Acoustics, which are our competitor in a way, but traditionally we shared the market, and there are 2 more or less different kinds of aesthetics people have. So for a lot of people, there's just an aesthetic choice between Junger and a product like the Linear Acoustic. So our product range is very, very focused on neutral and transparent audio processing. We're not using classic multi-band designs, which are very powerful, but they always have a coloration to the sound. So we're working with a so-called multi-loop design, where we extract different timings and different processing instances and bring them together without splitting the frequency range. So that's one of the most important differences from our algorithms to what many other companies in the world do. So just to have a gathered advantage or list of advantages that our products bring, we have a complete SDI infrastructure, which is very important for current broadcast infrastructures. So we're, of course, on the transition to going to an all IP or to an IP-based audio infrastructure, but the equipment available everywhere is still a lot of SDI. So we're offering a wonderful, like a bridging technology between the traditional infrastructures and the modern audio over IP world. I'm going to talk about that when we come to our current development project. So all of our products support all international loudness standards, which is very important. Junger has been one of the very first companies that adopted the ITU 1770 loudness recommendations. In fact, with our main loudness processor, Level Magic, we had a loudness-based or a power, electric power or mathematic power of the signal-based processor before the ITU came up with this 1770 proceeding for a standardized measurement. So the tradition of Junger with loudness processing is already more than 15 years almost. So all of our products include the Level Magic process. That is a very powerful, automatic, and most importantly, real-time algorithm for keeping control over the broadcast and production loudness. And just for the total integration, where all of our products are equipped with a full-blown Ember Plus protocol interface. That means that ranging from just having virtual GPIO for easy switching up to a full automation and virtualization of our devices, everything is possible in between. So almost all automation companies currently have Ember Plus as a protocol implemented. So having the Junger products in a sophisticated automated environment is a very, very easy thing to do. Let's get into our product portfolio. Our current range is split into three main parts. The first one is the well-known DAP series, aka Slimline. You will find those two names just equally. So we're internally we're always referring to the DAP series. The DAP series is a 19-inch one rack unit devices series based on two main boards, equipped with the same DSP power, with the same basic infrastructure, the same interfaces. The main difference is that they have one has the capability to process up to 4 channels, which means 2 times stereo, and the other one has the capabilities to process up to 8 channels, which makes it capable of 4 times stereo or surround 5.1 plus stereo. So that's the main difference between those two. The second difference is the bigger main board is able to get equipped with the Dolby hardware codecs. So with the bigger device, you can get all the current very important codec solutions from Dolby. And I'm going to drop into that as well in a minute. All of our devices support interfaces in many formats, SDI, AES, MADI in BNC and optical, and of course, Dante, so that our devices can be an interface solution between a Dante audio over IP-based infrastructure and a broadcast environment, which is, for example, very helpful when you're working with a live audio somewhere and an OB van, for example. The DAP series brings all the renowned Junger audio algorithms. That means, of course, level magic, our upmix, spectral signature, dynamic equalizer, and many, many more, up to our FM processor, the FM conditioner, which is a very, very powerful MPX limiter and spectral limiter that is very popular with German like culture radio stations or classical music stations, because it's very, very low intrusive. It's not coloring the sound very much, so you have full protection for your FM transmitter when you don't want the big coloring devices, which are valid for many, many other types of adult contemporary or pop music stations. So this is just an alternative for more transparent aesthetics, let's say. Okay, so here's just an overview over the two main boards, and here you can see which of our DAP products are based on which of those two main boards. So the DAP8 is the big processor with all the algorithms I already mentioned. You can equip this with two interface boards. You have AES on board, you have the full network control, and we have a second big product based on the DAP8, which is our map or monitoring processor. And this is a very special device because it's not only a monitor controller with capability up to 7.1, but it's a full-blown loudness measurement solution with 4 additional independent measurement instances inside. So you can measure up to 5 independent programs when you're working in a QC room, for example, and you want to keep control over more playout path than just one. So you control 4 playout paths just on the measurement, and you're working with one of those paths in your monitoring system. And the third and maybe most important advantage of the MAP is the capability to replace many of the old and no longer available DP series devices from Dolby. So a lot of people will know the DP570, which is the multi-channel audio tool from Dolby, and which is no longer available for a couple of years now. But also the 571, which is a Dolby E encoder. And as you can see here in this chart, we have additionally we have the DP563 ProLogic encoder and the LM100 loudness metering. So all of those 4 products can be replaced with one MAP, with just one instance without all the hassle, and that's quite useful with a very sleek and touch-capable new interface. So what we did here is we created a touch-capable interface that contains all the main parts you will need in a QC or monitoring situation, where you have the monitor control on the right, you have all the metering on the top, and you have full control over the metadata of all the Dolby programs you're working with. So you get full control, you get the full Dolby metadata emulation capabilities within just one device, and it's all just working out of one box. So this is the good replacement for all those very old DP units, and it's, as you can see, it's featured from Dolby also. It's, of course, it's an officially tested alternative to the old product range from Dolby. Let's go on with the DAP4. The DAP4 comes with 2 versions again. The first one is the stereo audio processor, where you can process up to 2 stereo programs. Here you have all the algorithms available for TV processing. And on top, we have the already mentioned FM conditioning, de-esser, and phase rotator algorithms available for the radio processing, if you're more on that part of the market. Again, it's all completely controllable from the web interface, and you get full Ember Plus integration. The DAP4 has only one slot for expansions. So you have to decide which of the formats you want to use with this. Then you have the AES interfaces. Again, you have the web interface and the full reliability of the DAP series. The last product of this range is our voice processor, and the voice processor is very important for us also because it's not a simple single or dual channel audio processor, but what we do here is we have two parts of processing. So we have two microphone or voice processing channels with all the very important tools for a really comprehensive sound control, for live microphones, for voiceovers, for whatever comes in. And as a second path, we have full control over a program. So this could be used for an IT, for example. I always mention this example from the United Kingdom, where they use this product for processing of the Champions League football games. So what they do there, they have one or two people commenting over the live audience coming in, the stadium sound coming in the program path, and we bring it all together in the voiceover section, and then we have Level Magic as an output loudness controller. So that means that the output of this mix from those two or three sources is already broadcast ready and can be sent directly to the playout system or to OB1 or whatever is your playout in the end. So the voice processor is way more than just a channel strip. It's really a full solution for production of live sound, for sports, for studio production. It's very convenient and very flexible. Then we are going from the DAP series, we're going to the Easy Loudness. Easy Loudness is based on the very same system as the DAP4. So in fact, this is a DAP4 with a simpler front panel. That's in hardware, that's the only difference. So you get the full reliability and the full quality of the processing from the DAP series at a much lower price. So this comes pre-configured in two versions. The first one is the Easy Loudness SDI with a 3G SDI interface with video buffering. So you get your lip sync directly in the box, and you have full loudness control with a very simple web interface where you just set up your loudness standard, and it's a fire and forget system in the end. So you just select, this is my input, this is my loudness standard, and then you say go. The second product of this range is the Easy Loudness Audio over IP, which is basically the same, except that there's, instead of the SDI, there's a Dante interface. This Dante interface is capable of running in AES-67 mode, so you can integrate this into a more complex or in a bigger audio over IP infrastructure also. So this is our entry-level product in the 19-inch one-rack unit series, without any difference in processing quality. So this is totally the same. It's a DAP4, which is just reduced in number of features and in the front panel. That's it. And then we have the second big series of products based on our C8000 system. And the C8000 is a very complex card-based system where you just select and integrate the cards you need for your application. This card-based system has several different products. One of them is the Junger Audio NetBridge UHD that converts 4 up to 4 SDI streams that can be part of a 4K 4-quadrant SDI signal, and you can convert this or interface this to a Dante infrastructure or to a MADI infrastructure. So you have MADI and Dante in parallel here, and you can bridge between SDI, so between the broadcast world and maybe a live mixing desk or maybe a Dante environment. It's up to you. So it's very flexible. You can use all 64 audio channels from the 4 SDI and convert them into a different format. But of course, this card-based system is so flexible, you can set up any kind of processing. One of the most important applications here is that you can use all of these cards with independent sync base. This is the only system that can have a so high density ratio of SDI-based independent program processors on 3 units, 3 rack units height. So having a lot of channels in a complex playout system, or having programs coming from different stations to go to a satellite uplink, for example, this is the most density per SDI you can get with full processing, with upmixing, with level magic, with dynamics processing. And of course, all of those are working with all international loudness standards. It's full control by web interface. And again, even this card-based system is fully controllable with the Ember Plus protocol. So this is it for the current running portfolio. And now I'm going to present you our next generation of products and our next generation of audio processing. So we're currently working on a new system, which is completely based on a full new infrastructure and a new environment. So we took all of our algorithms from all those currently DSP-based processors, and we took a Linux real-time modified operating system and put this all together to one big system called FlexAI. So FlexAI stands for Flexible Audio Infrastructure. You get this is not an application, this is a full system. So this is running on any x86 processing system. You can use either your own server infrastructure. You can buy servers from us, of course. In the future, you will be enabled to use this on virtual machines or even in the cloud. This is something that just needs to be really considered carefully because of the latency that is introduced by those virtualization systems. But in the end, this is a system that can run on anything that is based on x86 CPUs. So this is our system that is not only flexible in terms of running everywhere, but also in terms of scalability. So at any point with FlexAI, you can buy new program channels and just add them up by adding licenses to your licensed system. So whenever you need more channels, you just buy licenses from us. Whenever you need more processing, you buy licenses from us. In the very near future, we will have the capability, the system is already prepared for this, to rent licenses. That means you can just rent channels for the Olympics, for example. There's a big sports event coming up, not this year, but next year, hopefully again. So you just rent additional processing capability for 3 months. And after that, the system, of course, does not stop working, but it tells you, okay, we're running out of this license. If you want to use it any longer, you should reroute those systems and get rid of the rented licenses, or just buy new time or fully buy it. So there will be rental models coming up with this new infrastructure. And the cool thing is, whenever you run out of CPU, you can set up a second server and run them together. So this is really scalable in all of the aspects. And the cool thing for us is that this new infrastructure is totally under our control. So we have full control over the operating system. We have full control over the audio processing. And you may think, okay, now Junger goes all software and Junger goes all software-based processes. That's true. But in the end, we are still working with hardware in many, many, many occasions, even if you're just using them as interfaces. So what we did is we built a full new processor called the Expressor. And the Expressor internally is totally based on a CPU, on an x86 CPU. That means that this processor can run the exact same software that I mentioned before. So the Flex AI system is running either on third-party hardware or on our own audio processing device. So the Expressor really is the successor of our DSP-based processors, of our range of processors we had all over the years. If you look closely, you notice that I already put the Expressor in this row of hardware in the very beginning. So this is the Flex AI system is not going to end the tradition of hardware-based Junger products. It's just the next step, and we're very flexible because we can combine the software world with the hardware without making compromises. We don't have to develop two platforms. We don't have to care for introducing new algorithms on more than one platform. We're just doing it within one software realm, and we're doing it for all the products, no matter what you need. So the capabilities of this Expressor are quite impressive. Internally, it's capable of a near zero latency. So we're talking about 12 samples latency in total from interface to interface through the CPU. And this really, really fast routing system is based on FPGA that is capable of 3,000 by 3,000 connection. Each connection with gain and each input with metering. So what you get on the hardware side already doesn't need to be calculated in the software, so it's no load on the CPU when you're just using this as an interface solution. The hardware latency is very, very low. That was very important for us because, as I said before many times, we're really our main expertise has always been real-time digital audio processing. So we're not parting from that way. We really built a product that is in the tradition of the older devices. It's all low latency. We're talking about a full processing latency of 3 to 10 milliseconds. 10 is quite a lot already when you're using look-ahead systems and when you're working with big FIR filter banks, for example. In the baseband, we have a lot of interfaces already on board. And the cool thing is that we have the AES-3 and the analog interfaces can be switched between 8x8 input-output configurations and 4x12. That means the analog and AES can have up to 12 parallel outputs, which means you can use this, for example, with a full 3D audio configuration with 7.1 plus 4 height loudspeakers, for example. So you get full control over 12 loudspeakers in an MPEG-H or Dolby Atmos environment. And it's all included in the mainboard already, so you don't need to add additional cards. As you can see here on the next page, you can see it better. This system is also capable of adding interface cards to the already onboard interfaces. And the practical thing for us, which made the development very, very fast, is that those cards are the exact same that we're using in the DAP series. So from the very beginning, we could use all the interfaces taken from the DAP and put them in our new processor to have them already available. So the Expressor and the Flex AI system are, of course, still under development. The Expressor is already rolled out, but the software, of course, is under development, but it's already released. So it's easy to invest in a basic system now and upgrade this later, add more features as they come up. We're not going to replace the DAP series with the Expressor currently. So this is a product that is put on top of the range. But as time goes by, of course, we're starting to replace them one after the other. So it's it's a work from top to bottom in a way. What I just said is very important. We're not going to discontinue the DAP series currently because it's probably one of the most reliable audio processors currently on the market. And this is something that we're very proud of and that we're not going to let go easily. So this is something that will be with us for a lot of time to come. Back to the Expressor, there is more to this than you see. Of course, the system is based on audio over IP, so whatever you do, you get full Ravenna and Livewire integration without using the Dante interface, for example. So you can add a Dante interface and you have a full bridging system between Ravenna, Livewire, or Dante. So it's all just part of this full system, but of course our main focus is on running the open formats like Ravenna and Livewire from our friends from Telos. We're working very closely together on the technology, by the way, so we're not simply a arrangement of marketing and sales and distribution. So we're working very closely with the guys from Telos to have really take advantage of the technologies from both of our companies and bring them together for the maximum possible advantage to the customers. So Ravenna and Livewire is integrated, and then you can see there are two SFP cages, and they bring redundant MADI already on board, but they can be switched to a second interface format. As you can see here, we call this the Tylite interface, and Tylite is a SFP-based optical interface capable of 1024 channels per direction redundantly. That means what you do is you take a server, just a commercial off-the-shelf server, and you integrate our PCI Express card, which is basically just a part of the main board put on a PCI Express card, and you connect the FPGA from the card and the FPGA from the Expressor directly to.
Friedemann, there is a problem on the connection. Andrea, can you check about the connection?
Having a 12-core Xeon processor, or even bigger, I don't know, doesn't matter, for the audio processing. So you just connect them, and the system is load balancing. So it's just distributing the CPU power between the Expressor and the other devices. So just running out of CPU, you can add the server and run this. Actually, this system is already available with our MPEG-8 3D audio authoring and monitoring system called MMA, which is using a server for running the software and using the Expressor as its interface, where you can just integrate up to 4 interfaces of any format, mainly SDI, of course. Audio over IP is already there. So it's all just in one very big package that can be upgraded at any point, that is supported for the future, where we have control over all those security aspects, because now that we're all going network, we're of course becoming vulnerable to external attacks. So our systems need to be very safe and very reliable, and so then it's important for us that we, for example, have security patches directly on the system without having to install new firmware on a device. So we can really upgrade all the aspects of the system individually. And it's very flexible and very intuitive. And it's, with this capability of so many channels, we thought Flex AI for the audio infrastructure is a very good name in the end. So here's just, again, the numbers for the Tylite interface, which is our cascading system. Of course, with this system, almost any virtually any media interface currently available can be integrated into this system, or maybe is already there. When you're talking about audio IP, MADI, analog, and AES-3, that's quite a lot already. With 4 SDI cards, you get a very, very big solution for the traditional environment and for the audio over IP future integration that you're probably going for within the next time. Yeah, that's it from me for the moment, and I'm handing back to Fiora.
Thank you, Friedemann. Thank you for this complete overview on the Junger product, a very interesting product. And let me say that if someone is looking at us and need to forward some question to you, they can write on the YouTube chat, and we can forward to you the question. Same for Larry. And let me also introduce Andrea, that is following us for this seminary. And this time now we can go to Larry. Larry, you are here. Can
Yes.
You are ready to talk about your technology?
I am. Let me share my screen here. I'm actually going to...
Okay. It's working, and we can see your screen. Thank you very much, and please go ahead with your presentation. Thank you.
Oh, good morning. Good afternoon there. I'm going to start by going through some explanation of just general technologies that are coming for next generation TV audio, and then I'll talk about a few of our products that will address these. So the first concept, let's change slides here. Here we go. Channel-based audio. And this is how we're thinking, this is how we've thought of audio and have worked with audio for years, for decades. We're looking, it's a very output-centric way of thinking of audio. We have a left and a right speaker. Or we have 5.1 with the left, center, right, left surround, right surround, LFE, and we have to mix everything to those channels. Looking forward, there's something called object-based audio. And this is a very input-centric way of looking at audio, where each sound or element is its own object, and with that, it has metadata associated with it. And that metadata can be positional information, what level to play it back at, frequency response, the size of the object, how to move it. So these are all things that are a new way of working with audio. MPEG-H uses this, Dolby Atmos uses this, and other systems as well. And I just mentioned Dolby Atmos. Dolby Atmos is their brand name for immersive audio. And Dolby defines Atmos as an immersive audio experience. And this really started in the cinema space, but now we're seeing it move to broadcast and to delivery to the viewer at home. And they use a much simpler implementation to deliver it to the home, but it still delivers a really, really compelling experience. Now, Atmos or immersive audio adds more channels, and typically height channels, but it could be more channels at the ear level or even on the ground. This can be done with channel-based audio. It can be done with object-based audio or a blend of both types. And that's typically what you'll see in the cinema. For Dolby Atmos, today, that can be delivered with Dolby Digital Plus Jock. And that supports channel-based audio. But AC4, which is a new technology from them, will support Dolby Atmos as well, and that can support channel-based audio and object-based audio. So again, Atmos started in the cinema, and here you see all the individual speakers. Well, those are amplified individually, and there's a large processing engine in the projection booth that takes all those inputs up to 128 and does a real-time mix down or render, knowing where those speaker locations are, to represent the audio where it should sound like it's coming from, regardless of the speaker configuration. Well, that's a little bit difficult to do in the home. So in the home, it's done a little bit simpler. But in the home, you can actually experience Atmos today on Blu-ray or on online streaming services such as Netflix or Vudu. And now there's music services that are offering immersive audio music. There's Tidal and Amazon Music that offer Dolby Atmos music. In broadcast, here's a list of pay TV services and broadcasters that have done Atmos broadcasts before. Some of these names might be familiar. I think one Artur might be very familiar with. And how do you get it at home? Well, many devices support it today. So you can already receive an Atmos signal at home, be it with a television, an AV receiver, a media player like a Roku, video game consoles, tablets, even mobile phones can give you a Dolby Atmos experience. And if you don't want to hang speakers everywhere in your house, you don't have to. There are upfiring speakers to give you a Dolby Atmos experience. And again, I'm saying Dolby Atmos specifically here, but this works with MPEG-H or any immersive audio. So the concepts are the same. Soundbars will be a very popular way to recreate that experience in your living room. Even Amazon is in the game now with their Amazon Echo Studio, which gives can give a quite impressive Dolby Atmos experience with 3D music. The common formats that we'll see in broadcast and delivery to the consumer are really 5.1 plus 4 overhead channels looks to be the clear winner for this. But there are others. So 9.1 plus 6 is a format that's commonly found in cinema, and that may get distributed out as well, but that would be to the consumer, but that would typically be on something that is coming from Hollywood, a post-produced type piece, not so much of a live sporting event. But 5.1 plus 4 looks to be the most common format factor going forward for broadcast. AC4 is Dolby's newest generation technology for audio codec for emission. It's much higher efficiency than Dolby Digital or Dolby Digital Plus. You can see here a list of data rates. So a stereo signal can be down to 64 kilobits per second compared to Dolby Digital, which was 192 kilobits per second. So you can see that this is a far more efficient codec to use for the same level of quality. And it also supports other features such as immersive audio and personalization. And this is where things get interesting with the personalization, because the way this works is also a little bit different way of thinking than what we're used to dealing with in broadcast. Today in broadcast, we're used to dealing with a complete main stream. So what that means is you send a complete mix out. And that complete mix includes all your effects and bed music and your dialogue, all mixed together. You know, and in many regions of the world, they have to send multiples of these because of the different languages. With AC4, the personalization works. You send in your M&E mix to the encoder, and your individual dialogues, and perhaps your audio description track for the visually impaired, and other sounds. And the AC4 encoder can send those as individual substreams, all in a single AC4 bit stream, to the consumer's receiver, where the receiver will actually assemble the final mix and do part of the mixing itself based on metadata that is set upstream during the authoring process, and by the user's selections. So the user can select, I want the Italian dialogue, I want the English dialogue, or I want the Polish dialogue to hear. And I can turn on or off the AD track as I want. So this really gives the viewer much better control. And like here in America, typically with multiple languages, broadcasters will send out a 5.1 program of the primary language, and then they will send out a secondary language with just a stereo mix, sometimes mono. And the same thing for the audio descriptive service. It's a complete mix, and that is stereo or mono. Now, if the broadcaster chooses to implement receiver mixing and going with an advanced bit stream, then the primary language and the secondary language, and the person who is listening to the descriptive track can all get the surround mix as well. And many times this can be done at a lower overall data rate than what they were doing before, even just with a simple 5.1 complete main. So there's really some new advantages in the newer codecs. There's also dialogue enhancement in here in AC4, and it also has Dolby's real-time loudness leveling, which is a little bit simpler algorithm than Apto or Aero that we offer at Linear Acoustic. So you can get a much more control using Apto or Aero and fine tune the sound that you want. Still, also AC4 is video aware, so this aligns with the video frame boundaries for perfect routing and switching. If you're familiar with Dolby E, this is a similar concept, the same concept actually, but if not, what happens is the AC3 frames, Dolby Digital, those are 32 millisecond frames. So those never quite line up correctly with the video frame boundary when you go to switch. So when you switch Dolby Digital through a broadcast plant, what happens is odds are you are destroying a Dolby Digital frame on either side of that switch point because they just line up randomly. With AC4 and Dolby E, they're video aware, so they make the frame size fit within a video frame, and then they pad it out with zeros so that you're always switching. That switch point always occurs in silence, so that you're always guaranteed a clean switch in the audio as you do with video. So that's about AC4, the technology. Where it's being adopted, many countries, including in Italy, have written AC4 into their next generation specifications. We'll be using it here in America as part of our ATSC 3.0 specification, and there's a big launch this year and next year here in the US for the next generation TV service called ATSC 3. But internationally, AC4 has been adopted, and you can recognize, several of the agencies that have adopted it, including DVB and the Ultra HD Forum there in Italy. So you will see AC4 coming your way here. So that's what I wanted to give for an overview of where next generation audio is going. Some of our products to address this. The first one is the UpMax ISC, and this is an upmixer, standalone upmixer unit, and this will upmix from stereo or stereo plus a separate dialogue track, 5.1, 7.1 inputs. This will generate that immersive audio output for you, and this will give you a consistent output. There's also, it can work in a legacy mode if you're still working in 5.1. And you still want to upmix stereo to 5.1, this will allow you to do so. But it can also upmix directly to a 5.1 plus 4 or 7.1 plus 4 output. This includes automatic pass-through if you want. And it will auto-detect what mode it needs to upmix from. So you can throw stereo at it, 5.1 at it, or 5.1 plus 4 at it, and it will automatically do the correct thing and go into correct processing mode. When we pass through, we're doing the pass through in software, and we maintain the same latency when we're passing through as we do as we process. So there's no change in lip sync when passing through or processing and upmixing. And this is a PCM only unit. So this unit does not support coded audio at this point. Where can this be used? This can be used in several places in the chain. The latency is low enough that you can insert this onto a mixing console and use this during your production. Many times, even though you may be doing a production in native in immersive audio, there will still be highlight reels from prior matches or interview clips or music beds and replay pieces that may be in stereo or 5.1 that you want to upmix to maintain that consistent sound field. So even in a native immersive audio production, there's still room and need for upmixing within there. So the UpMax ISC can do that in a live production. This can also sit in the air chain at the broadcast center. So that, say you're receiving an immersive audio production coming in from the venue, but many of your advertisement playbacks or your interstitials for your upcoming programs are in 5.1. The UpMax ISC can sit in the air chain and automatically upmix the segments, interstitials, and advertisements that need to be upmixed. This includes video delay on the SDI path, so AV sync, lip sync can be maintained without an issue. So that's not a problem. Here in America, one of our large sports broadcasters, NBC Sports, has been using prototypes of the UpMax ISC for the past 2 seasons for large university American-style football games with the University of Notre Dame in South Bend, Indiana over here. And they're very happy with the sound. They will be using these during the next Olympic Games. Unfortunately, that'll be next year instead of this year. But, American TV viewers will be hearing that. These university football games here, they draw very large crowds, as you can see by the size of the stadium. It's a very, very popular broadcast here every Saturday during football seasons. And these stadiums here will hold 80,000 people or so. So this is a large broadcasting events here. The next unit is our LA 5291.
Before moving on, just one quick question regarding the UpMax. Regarding the legacy mode, so is the upmixing in that sense the same one we can find in the Aero lineup? And if so, is the new UpMax coming to the new lineup? I know this deals with immersive sound, and the Aero lineup currently doesn't process that. But is there going to be let's say, backporting, or is it going to be just a standalone unit?
So this is a new algorithm, completely new algorithm compared to the upmix that is in the Aero units. We call it legacy mode. So it sounds very, very similar to the one that you find in the Aero units. But this is a completely new algorithm from the ground up. At this point, we probably will not integrate this new algorithm into the Aero units. People are very happy with the sound of that, but we needed to update it to be able to handle immersive audio. So we put the legacy mode in so that the new products that use this ISC algorithm can get a sound virtually the same as what you get in the Aeros, but this has the additional features. So this will most likely just be going in newer products from here on out, and instead of being retrofitted into the Aero units.
Very clear. Thank you a lot.
Mm-hmm. The LA5291 encoder. This is our real-time Dolby Atmos encoder for using Dolby Digital Plus Jock. So this is how you would be able to get Dolby Atmos today. Excuse me. This will encode PCM directly into the Dolby Digital Plus Jock bitstream, the Dolby Digital Atmos bitstream, or just a single 5.1 Dolby Digital Plus bitstream. This can transcode Dolby ED2, which is an updated version of Dolby E to support Atmos, and it includes more channels. It'll do up to 16 channels of audio in 4 audio channels or 2 pairs, but it also is updated to support Dolby Atmos metadata. So we can transcode Dolby ED2 directly into the Dolby Atmos, the Dolby Digital Plus Jock bitstream, or we can encode an ED2 signal with this unit or decode ED2 or Dolby E back to PCM. And this unit really is designed for the live, real-time Dolby Atmos workflows. Looking at the hardware, it's a 1RU unit. We have 5 pairs of AES-3 I/O, so you can support 5.1 plus 4 input and output directly via AES. It has 3 gig SDI, and it has 2 Ethernet ports, one for control, one for AES-67 in support of SMPTE 2110-30, the audio portion. There's also a VREF in, old analog VREF in, tri-level sync input, dual power supplies, universal, web browser control, but there's also an option card slot. And the option card can be either another SDI card to bring the unit up to quad link 3G SDI for the 4K workflows with Dolby Atmos, which what we're probably going to see is Dolby Atmos paired with 4K video in the industry, much like 5.1 surround was paired with HD video 20 years ago. I think we're going to see the same kind of marriage here with 4K video and immersive audio. Another option card will be MADI I/O, and then finally a third one will be a high-speed Ethernet card in support of ST2110 workflows that include the video, so that we'll be able to delay video in the 2110 domain as necessary to maintain proper AV sync. This can fit in several spots in the workflow. This can sit in the OB truck to encode a Dolby ED2 signal, or it can encode the Dolby Digital Plus Jock bitstream directly. This can sit in the broadcast center to encode or decode as necessary to deliver the final Dolby Atmos bitstream to the viewer. So in the OB truck, this would sit, you would receive audio coming off the console. And then it would use a Dolby DP 590, which is their metadata authoring tool, and that would push the metadata via an IP link over to the 5291 for proper encoding. In the broadcast facility, this can decode the ED2 stream that's coming in back to PCM, and the PCM can be routed through the broadcast plant, mixed in with studio shows that are done there, and then the final output would go through another 5291 to be encoded into the final Dolby Atmos bit stream, which gets delivered to the viewer. And our third product is the LA5300. This is an AC4 encoder and transcoder. This uses, it has the same I/O and options for I/O that the 5291 and actually the UpMax ISC have. This will encode PCM into AC4. This will also decode Dolby Digital, AC3, or AC4, and allow you to process it and re-encode. We're calling it an ATSC1 option, but this will include our Apto loudness control and Dolby Digital or Dolby Digital Plus encoding. UpMax ISC algorithm is built into this unit, along with options for watermarking, and there's bitstream analysis for each of the outputs, and there's a confidence monitoring output on here. So here's kind of the workflow of a processing block that's in the 5300. You can see we can accept a PCM input, a Dolby Digital input, or an AC4 input, and we can decode those. We can pass it through the upmixer if desired to provide a consistent output regardless of the input format channel configuration. That can get watermarked and then fed to the AC4 encode. Alternatively, we can just simply pass through a pre-encoded AC4 bit stream. And then here's your bit stream analysis block, so you can ensure that all your metadata settings are correct, and that the output of the encoder is running properly. And then this also feeds off to the confidence decode block. And within the 5300, we're actually looking at getting 4 processing blocks in here with a single instance of the confidence decode. So that's those are our new products and the overview of our next generation audio, where things are going.
And thank you very much to Larry for the explanation about this very interesting technology. Andrea, if you don't have other question, we can say to Artur to follow up this webinar.
I do have a question, and that would be...
Okay, thank you.
This is either for Larry and for Friedemann. If there's any roadmap that you would like to share regarding future updates, since everything now is software-based, what is the roadmap for new features and upcoming features that you want to implement in these products?
I'll go first. We're actually currently in the process of updating our roadmap for these newer products. So there's not much new that I can share at this point, other than the products that I just talked about are just getting ready to start shipping once the world opens back up. So now we're kind of going in a planning cycle at this point for what we see next for these units.
And Friedemann, up to you.
Yes. For us with the FlexAI and Espresso platform, the biggest step we're currently working on is the Livewire Plus integration, so that we're really fully becoming part of the Livewire family. So this is something that is scheduled for summer. So as we're already in May, we're talking about the next 2 to 3 months. Then we're rolling out the Livewire, which is very heavily focused on those interoperability. Sorry, you know what I mean?
Yeah.
Standards like 2110-30 and a very important 2022-7, which is the redundant network connection standard. So we're really currently focusing on the audio over IP world with all their important standards, and then we're rolling out all the processes one after each other. So currently we have the basic equalization dynamics in Level Magic, and we're introducing the upmix and stuff. So we're currently also rescheduling our roadmap because of the missing shows, because we couldn't go for NAB. NAB was cancelled, and we're not sure if we can go to Tonmeistertagung and if we can go to the IBC in fall this year. So currently we're rescheduling all those release dates from a trade show based calendar to having it like a constant rollout of products. But just as Larry said, our Expressor and Flex AI system is shipping. And if the world opens up, it's all available. You can get into the system now and include features at any point in time.
Actually, you said something really interesting from my point of view regarding the Livewire Plus integration. Will that be just for the audio parts of the Livewire protocol, or will you also integrate the Livewire control protocol? Because you said the machines are Ember Plus, they support Ember Plus. So will they support both Ember Plus and Livewire control protocol, or will the remote control just be Ember Plus?
This is a very, very good question, because also besides Ember Plus and the Pathfinder protocol, there is also AES-70, for example. So there's a lot of control interfaces on our roadmap. And yes, we are going to implement at least certain features of the Livewire Plus control interface into our products, of course. But this is something that is not scheduled for the next part of the year. So maybe coming to winter, we're starting to roll out interface solutions with Livewire Plus. Currently, we're focusing on the audio over IP part of it. Yes, but of course, our goal is to become fully Livewire Plus compatible in all aspects. Yes.
Perfect. Thank you a lot.
Yes, thank you, Friedemann. And after Larry, we come back in Europe to Artur. And Artur, you can follow up. And seems that you are not really in Europe, right? We can remember that where you stay now.
Okay, so Larry is of course San Francisco, so it's very, very early for him. I'm in Warsaw, so I will be very happy to do some small, let's say, attachment to what Larry was saying. So he was talking about the very nice products like the LA 5300, like the 5291, and I wanted to show you something that's let's say that's a little bit more easy than this. And this is our ARC. This is a machine that we, let's say, we introduced a few months ago. So it's absolutely on, let's say, on our topic. So we can deliver it anytime. And this machine has been created to, let's say, to solve the very simple things. So with this machine, we do not do anything fancy like 5.1 Dolby. We just do stereo. But for this machine is very price effective, and it's doing it very, very clever. So I will be very happy to show how it looks. So the ARC, automated real-time control, this is a machine, as I told you, designed especially to handle only stereo. But for this, it does it very, very clever way. So we're using the Apto algorithm, the same that we're using also in the Minnetonka software, the file-based software. So in this case, we are doing basically only PCM processing. So we don't do anything like coded audio, like the Dolby, like nothing like this. So we support only stereo programs. Even if we have a 5.1 programs, it will be down mixed to stereo only. So we have two independent engines, which means we can do two completely independent encodings or decodings, however you want. And we have, of course, everything, including inside the control, like SNMP, like GPI, and so on. The machine is very, very simple to use. You can have the complete, let's say, solution in 5 minutes. I will show you simply how it looks like. So this is the machine from the front and from the back. As you see, we have the AES input, we have the SDI input. For now, we have just one SDI. And on the roadmap, we have also the machine with two SDI inputs, independent. And as you can see, we have two network interfaces. We have the control port, but also, which is very, very important, the native AES67. So the input and output, SDI, so we do 3G SDI, of course, HD, SD, whatever, AES3, and we have up to 16 channels of AES67. For this, we have also a GPI connector to do 5 inputs and 5 outputs. So we can simply get the information from the machine, but we can also control the machine via the GPI. Now, this is a very simple block diagram. You can see from it. So we have two routers, two mixers, the input router and the output router. So which means we can take basically any kind of signal, we can mix those signals and put them out in any order that we want. So which means we can mix SDI signals together with AES67 signals together with AES3 signals, however you want. We have also a video delay to compensate all this mixing that goes on in the machine. So the web UI, how it looks. If we log via any web browser to the machine, this is the very first page that we see. In this case, we need, of course, to log into the machine to make anything, any setups, any changes to the configuration. Now, when we logged in, this is the very first screen we see. So we see the input meters, left at the top left, and the output meter, top right. So we see what kind of signal are we getting. We can also see what kind of signal are we putting out, and we see, of course, the level or let's say the amount of correction that we're doing. On the left, you see this Apto loudness control. There we have the profiles. In the profiles, we can select a lot of things. So as I said, this is the very first picture that you see after the logging in. Now, to set up the machine, you click on these profiles on the left. Now, you see a whole list of the profiles you can select. So we have something like the factory profiles that are being delivered together with the machine, but you can also create your own ones. So in this case, the very first one would be the EBU R128. This is the European norm. Then the American ATSC A85 and so on and so on. But you have also a lot of different ones. So you can have, for example, a profile only special for music, for movies, for some voice programs, for classical music. You could have even profiles that are the very same like the radio processors, if you want. So the machine can be used, of course, in TV stations, but it could be also very nicely used, for example, for any kind of broadcasting of events, computer games, something like this. No problem at all. So you have the profiles. You can load the profile, you can change it, and save as your own profile if you want. So if you load the profile, you would see, this is the input meter section, you would see simply the signal that's coming in, the power of the signal, and then on the right, then you would see simply some additional data. Output meter would show you what you are really doing. In this case, this is the information, that's what you're sending out, including the adaptation level. So if you have, let's say, selected the profile, right, you can then in the next page, you can say what kind of input are you using to be processed. In this case, in this example, we have chosen the AES67 in the first pair, and the second profile you see here. So we have two profiles. The one is called Sky 1, the second is called HBO 1. So for the first profile, we have selected the input AES67. For the second profile, we have selected the AES67 input 5 and 6. This could be edited. You could select for the input, for example, AES3, you could select for the input any pair from SDI. Now, this is the routing. So for the SDI section here, so you select on the left the SDI, you see the labels for the SDI, and this is the whole magic that we do. So in the SDI out section, this is the routing you're doing. For example, in this case, you want to put on the very first pair of SDI out, let's say SDI. This is how you do it. You press it, and you can select the whole batch of outputs. You could select, for example, unprocessed SDI in 1.2, but if you select the processed profile, in this case, on the SDI pair 1 would be the processed one. You could have on the SDA, for example, 3.4, the second processed. So that means you, for example, you're coming in with the AES67, you process AES67, but you put this processed AES67 on SDI. So that means you are creating your own mix however you want it. We have basically no limits, so you can create any kind of mix of SDI and AES67 streams, however you want. Just remember, you're doing stereo processing. That means you can process two inputs independently, but where you put them, on which streams, it's up to you. So the very same for AES67. So AES67, these are the labels. You can put the address, so that means you are showing where do you take the source for this AES67, and then in the out, you can do the same. So this you can put into the AES67, for example, first pair, the processed program, second pair would be another processed program, and the other pairs would be, for example, unprocessed SDIs, AES3, or another AES67 streams. So that means you can also create in AES67 domain your own profiles, or you create your own mix however you want. So that means you could, for example, exchange the dialogues to another language. You could, for example, exchange the commentator to another language. Up to you. This machine, as you see, is very simple to do setup. The same for AES3. So you have, for example, for the AES3 out, also the processed system, unprocessed, whatever. This could be used maybe also as a kind of a backup solution, if you want. Then you have the GPI section to be, let's say, to control the machine, but also to get information about the state of the machine. In this case, you could, for example, reset the loudness measurement. Of course, we have built-in loudness measurement. It will work in a very similar way like we're doing in the arrows. So that means you have, for example, the short-term loudness measurement, 1 hour, 1 day, 1 week, and 1 month. And you can download everything like this into an Excel sheet. And then we have the system page. In this case, you can set simply the information about the machine. You can set some basic functions. You could set up, for example, if you want to save the system configuration, if you want to load the system configuration, you could change the password, things like this. And then you have the IP configuration. So as I said, we have 2 independent ports. So that means 1 port is only for the control, and the other port would be for the AES67. You could also provide a network address for the SNMP server for control, or say for information. And this is the system synchronization. Of course, because it's a linear acoustic or Telos product, we do exactly the same like with the other products. That means we can use the same PTP protocol like we're using for the Livewire. This is an AES67 device, don't forget. So in this case, we can also, of course, use the AES67 clock. And this is the final meta page. So this is kind of a system summary. So in this case, you see the complete overview. So you see what kind of inputs you have. You see what kind of outputs you have. but you can see also the very single input. So you see on the top right, on the inputs, you see everything that's coming on the SDI. You see everything that's coming on AES67, unimportant if it's processed or not. And then you can see the processed one. So on the output, you would see what you're really sending to the outer world. So that means in this case, whatever you have on the output, processed, unprocessed, it would be also shown. So you have a kind of a control what you're really doing with the machine. A little bit more about Apto. So these are algorithms that have been developed especially for, let's say, very sophisticated loudness control. In this case, compared, for example, to Junger, Junger is also doing very nicely this loudness control, but you could see it like this, that Junger is doing much more loudness control, not touching the flavor of the sound. We may change the flavor if you want. For example, we may have Apto algorithms that are being used especially for classical music. That means this loudness would be controlled to have the correct loudness parameters, like -23, for example, for European, or -24 for American. But in this case, also, we would change a little bit the parameters inside the profiles. So which means, for example, some bandwidth or some instruments could be brought a little bit more to the front. Some others could be hidden a little bit back. It's the very same, for example, if you have a lot of talking, if you have something like documentaries. So in this case, the voice would be set a little bit stronger than other sounds. We are doing this with the Minnetonka audio tool server. In this case, with Minnetonka, we're doing the file-based processing, but we modified the algorithm to be used in real-time application. So it's this very same level of sophistication, the very same level of, let's say, changing, but it works real time. And these are the parameters that we could change within the machine. So if you load a profile, there are some very basic things. For example, in this case, you will see the target loudness. You can change it manually if you want, adaptation, the true peak, and so on and so on. And also, if you know what you are doing, you are also allowed to do a lot, to change a lot of other parameters. Like, for example, some high-pass filters, thresholds, compliance windows, and so on and so on. These are quite complicated things. So usually we encourage everyone not to change them unless you know exactly what you do or you want to achieve some special effect. So you can do this. Whenever you change any of those parameters, you can save them as your own profile that can be used for any kind of, let's say, appliance in the future. Okay, so this is another thing. This is a linear acoustic line, but I think about ARC, that would be basically it. Okay, so I think that's about it from my side. So thank you very much.
Thank you to you, Artur. It's a very interesting machine, the ARC. We have experience in Italy with the Sum Station. It's a very good machine, very simple to set up and a very good sound. And I wish again to thank you for your time. And I wish thank you, Larry, for your time in the beginning, in the morning, for you from US.
My pleasure.
And thank you also for Friedemann from Germany about Junger and for your product that you share with us.
Thank you, my pleasure.
Welcome. If someone need to have some demo or try one of these machines, they can contact us directly and we can set up a demo. Thank you to everyone. Thank you for watching us and bye-bye to next time. Bye. Ciao.